All right, next we have parallelograms. So what I'd like to show you about a parallelogram is that if I look at this as my base right here, okay, and not because it's sitting on it, it's because it's a horizontal piece, I need a vertical piece to find the height, okay? So what I'm gonna do is I'm gonna come from this corner and drop it, make a 90-degree angle, okay? And I didn't put the 90-degree in because I'm gonna end up moving this. And I have my height right there. So what I want you to notice is that if I trace this triangle right here, okay, this triangle right here, and I pick that triangle up and do my, oopsies, I'm gonna do my best to just grab that new piece that I had. We'll see what happens. Oh, I did do it, okay, and I pull it over here. What I do, let me scratch off this triangle now. So let's draw it again and then get rid of it. Okay, if I got rid of it over there and moved it over here, oops, not the best demonstration, huh? What I have is a rectangle, okay? This length that I just chopped off is over here, so it's still the base. And then this is your height right here. So now it's a rectangle, right? So the formula for the area of a parallelogram is the same as the formula for an area of a rectangle. It's area equals base times height. Now let's make sure we still remember that the base and the height have to be perpendicular. I see a horizontal line, so I'll use this as my base, but you could also realize that the top could be your base because there's another horizontal line right there, okay? And then your height's gonna have to be perpendicular to that. So I'm gonna drop an altitude to it, right angle, this is my height. Please realize that you could have used this as your base, okay? But then I'm turning my iPad at a 90-degree angle. Dropping my height is a little harder for my eyeballs here, but then this would be my height, okay? It does, let me make that better right there. So that would be my height. So it does work. It's just the perspective that you have for it. Okay. Oh, speaking of, look at that one right there. Okay, so this one's find the area of the parallelogram. Area is equal to base times height for a parallelogram. So I'm looking for a base and a height. Bases and heights are perpendicular. So I'm going to see my two perpendicular pieces. There's this and this, okay? All right, so my height I can see is 11. It's labeled, which is nice. And then my base is not labeled, but what I know about parallelograms are that opposite sides are parallel. So my base is 14. Bring my calculator back up so I can have easy access to that. So I have 14 times 11. I'm not dividing by 2 because this is not a triangle. And I have 154 feet squared. All right, this one right here, area is equal to base times height because it's a parallelogram. I need the base, I need the height. All right. Bases and heights are perpendicular, so I see my two perpendicular pieces. My base is 6 plus 13, which is 19. And then my height's not labeled, it's unknown, so I'm going to call it X. And then if you zoom in here, you have this right triangle. It's the height of the triangle. It's one of the legs, so I can find it using Pythagorean theorem. X squared plus 6 squared equals 10 squared. X squared plus 36 equals 100. Subtract 36 from both sides, and then square root to solve. You only need your positive answer, 8. So the height of this is 8 centimeters. Plug in an 8 here, 19 times 8, and the area of this parallelogram is 152 centimeters squared. All right, let's go ahead and try some parallelograms in the coordinate plane, okay? All right, here's this one right here, -5, -4. -5, left 5, down 4. -3, 3, left 3, up 3. 6, 3, right 6, up 3. And 4, -4. Okay, so this is looking good. I'm going to make my parallel sides, one set, two sets. All right, formula for area of a parallelogram is area equals base times height. Area equals, I need my base and I need my height. Bases and heights are perpendicular, so what I'm looking for are a horizontal and a vertical line because that makes my life easier. If not, I'm just looking for two perpendicular lines. So I see a horizontal line, but I don't see a vertical line. So what we're going to do is we're going to make a vertical line connecting the top to the bottom. I like to do it at a vertex, but it doesn't have to be at a vertex. It could have been right here. Well, that's still at a vertex. It could have been right here. But it's got to connect the two you use as a base. Okay? All right, so that's 1, 2, 3, 4, 5, 6, 7. My height is 7. It's not switching. I guess we're going to do it in highlighter for the rest of the problems. And then my base, 1, 2, 3, 4, 5, 6, 7, 8, 9. So base 9, height 7, area equals 63 units squared. It's really not changing. There we go. Okay, this one right here, negative 3, 6, left 3, up 6, 5, 2, right 5, up 2, 3, negative 4, and negative 5, 0. Okay, let's go ahead and connect our sides here. And I look at this. Oopsies. There we go. Okay. All right, so I look at this one and I say, oh no, I don't have perpendicular pieces, right? Or I'm sorry, I don't have perpendicular pieces, yeah, but I also don't have a vertical and a horizontal line. So the first thing I want to say to myself is, hey, wait a minute, is this a rectangle? Because if this is a rectangle, then I can find the base or the base and the height using the Pythagorean theorem. And then I say, you know what? It doesn't matter that it's not a rectangle. I have an idea, okay? So what I'm going to do is I'm going to make this into a giant rectangle. If you're like, what? I'm going to make this into a giant rectangle, and then I'm going to get rid of the parts that I don't need, okay? This actually goes into what we're doing this second half of this chapter. So what I'm going to do is I'm going to make vertical and horizontal lines that connect my vertices. It's basically making a triangle, a right triangle on all of your sides. So it's like making hypotenuses on all of the sides of this figure. Because I don't know if it's a rectangle. I could check the slopes. But what I'm going to do is I'm going to find the area of this rectangle, okay? So let's find that. I'm going to do 1, 2, 3, 4. I don't want to count them like that because then I have to erase them all. I'll touch them and count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so area equals 10 times, and then I'm going to go the base. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's also 10. So the pink area, which is a hot mess, is 100 units squared, okay? But now what I have to do is I have to get rid of each of those triangles. Ugh, it's going to erase all my beautiful work, but let's do that. Yes. All right, units squared. So now what I have to do is I have to get rid of this. 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 And then I will know what's left over.